Nice.
So, good evening, friends. Today we will discuss about probability distribution. So, in the probability distribution, we have binomial distribution, Poisson distribution, normal distribution, and so on. So, in general, here we can classify the probability distribution into two types. The first one is discrete probability. Yes, good evening, friends. Today we will discuss about the concept of probability distribution. So in the probability distribution, we have the binomial, Poisson distribution, and normal distribution. So in general, the probability distribution is classified into two types. The first one is discrete probability distribution, and the another one is continuous probability distribution. So in general, discrete means it is a countable number of values. So in the similar way, continuous means it is uncountable or infinite number of values. So based on this, here we can represent our discrete distribution as well as the continuous probability distribution. So we have some example for the probability distribution. Here, the probability distribution is nothing but it is a listing of the probabilities of all the possible outcomes that could occur if the experiment was done. So it can be described as a diagram. So it may be the probability tree, a table, and also a mathematical formulas. So here we have the types of probability distribution. Yes, already we have discussed. So the probability distribution is classified into two types. The first one is a discrete probability distribution, and the another one is continuous probability distribution. So the example for the probability or discrete probability distribution is binomial distribution and the Poisson distribution. So in the similar way, we can give the example for the continuous probability distribution is normal distribution. So in general, the discrete probability distribution means, So already we know that it is a countable number of values. So in the binomial distribution also, binomial means binomial means binomial distribution. That means we have to assume two values. Here we can use two values. Especially here we can use zeros and ones. Zero is nothing but the probability of failure. Similarly, here one represents the probability of success. Therefore, here we can use probability of success plus the probability of failure. Therefore, the total probability should be 1. Therefore, here we can write P plus Q equal to 1. Right? Here you can see the example for the probabilities. So here we can use the head and tail, the tossing of coin or tossing of two coins. So this is the example for the binomial distribution. Suppose tossing 3 times a fair coin, you have to imagine the sample size S equal to 3 times head, then head, tail, head, tail, head, then head, tail, 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 head, tail, 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 head, and 3 times tail. So with this here we can represent the sample space. So in general here we can represent the x value. Suppose here we have to represent the x, that means number of x. Here we can give the values for the x 0, 1, 2, 3 and so on. Here 0 means there is no head. Similarly, suppose if one head means here we can put x is 1. Similarly, here 2 heads means here we can put x equal to 2. In the similar way, here we can put x equal to 3. Then we have to represent the frequency value for the 0 head, 1 head, 2 head, and 3 heads. So with this here we can write the probability value for the 0 head. The resultant value is 1 by 8 because out of 8 cases, here there is no head means here we have only one possibility. That means here the resultant value is 1 by 8. In the similar way, here we can write the probability value for the single head or one head. The value is 3 by 8. Similarly, here 2 head means here we can put 3 by 8. And also the 3 head means we can put 1 by 8. So in the binomial distribution, we have the definition. So binomial distribution is a discrete distribution which expresses the probability of one set of alternatives. That means the probability of success and the probability of failure. That is here we can represent the notation is P and Q. Therefore, the definition of a binomial distribution is P of x equal to x, it is equal to NCR, P power R into Q power N minus R. So in this case, just you have to know the basic meaning of these notations. For example, here N means number of trials. Similarly, here R means the number of successes desired. Here P and Q, yes, already know very well for this P and Q. Here P means probability of success and the Q means probability of failure. Okay, therefore here P of x equal to x, it is equal to NCR into P power R into Q power N minus R. So this is the general definition of the binomial distribution. So next we have some practice question in this binomial distribution. Just you have to go through this example. So in the binomial distribution, we have to understand or we have to study the basic things. The first one is mean of a binomial distribution. Or we should know the basic things. That means the mean of a binomial distribution. So in general here, the mean of a binomial distribution is NP. In the similar way, the variance of the binomial distribution is NPQ. Therefore, the standard deviation of the binomial distribution is the standard deviation sigma equal to square root of NPQ. So with this here, we can find the mean value of the binomial distribution. Therefore, here we have some example. Suppose if the mean value of the binomial distribution is 20 and its standard deviation is 4, with this we have to find the n value, p value and the q value. Just you have to apply the probability distribution or binomial distribution, NCR into p power r into q power n minus r. Here the binomial distribution means the overall p of x value, that is 20. Here sigma equal to 4. So with this here we can write the n value, or we can find the n value. Here n is 100, p equal to 1 by 5 and q is 4 by 5. Suppose if the mean value of the binomial distribution is 20 and its standard deviation is 7, means you have to find the n, p and q. In the similar way here you have to find the n, p and q. This is for your practice. So next we have the concept of fitting of binomial distribution. So they will give some x value and the corresponding frequency. So based on the xn frequency, we have to fit in the binomial distribution. Yes, already we know very well of the binomial distribution. That means p of x equal to NCR into p power r into q power n minus r. So we have to fit the binomial distribution for the given problems. For example, here we have 4 coins. Our 4 coins are tossed 160 times and the following results were obtained. Number of heads 0, 1, 2, 3 and 4. And the corresponding frequency values are 17, 52, 54, 31 and 6. So with this we have to fit the binomial distribution. So in the similar way, we have to fit another problem based on the fitting of binomial distribution. Suppose here x values are 0, 1, 2, 3 and 4 and the corresponding frequency values are 28, 62, 46, 10 and 4. So next case is Poisson distribution. Poisson distribution is also one of the discrete distribution. So the definition of the Poisson distribution is P of x equal to e power minus lambda, lambda power x divided by x factorial. That means if lambda equal to mean number of occurrences of an event per unit interval of the time space, then the probability that it will occur exactly x times is given by, here we can use P of x or probability mass function P of x equal to e power minus lambda, lambda power x divided by x factorial, where E is an Ampere constant, therefore here E equal to 2.7182. In the Poisson distribution also we have some mean, variance, standard deviation and so on. Therefore, the mean of a Poisson distribution is lambda. It is equal to NP. In the same way here we can use the standard deviation of a Poisson distribution, square root of lambda. So the speciality of a Poisson distribution is both the mean and the variance are equal. So this is a speciality of the Poisson distribution, right? So we have some characteristics of a Poisson distribution. The first one is it is a discrete distribution. The next one is occurrences are statistically independent. The next one is mean number of occurrences in unit time of in a unit of time is proportional to the size of units. Mean of the Poisson distribution is lambda, it is equal to NP. Then variance of the Poisson distribution is also lambda. Then the standard deviation of the Poisson distribution is square root of lambda. It is equal to square root of NP. And the next one is it is always rightly skewed. And the last one is Poisson distribution is a good approximation to the binomial distribution when n is greater than or equal to 20. And p is less than or equal to 0.05. So these are the main characteristics of the Poisson distribution. So next we have the last concept, that is normal distribution. So the example for the continuous probability distribution is normal distribution. Continuous. So already we know very well for the meaning of the continuous probability distribution. So it means it is uncountable number of values or infinite number of values, right? So it is a continuous probability distribution, that is a random variable can take on any value within this given range. For example, here we can take the heights, weights, or marks, etc. The normal distribution developed by the 18th century mathematician, astronomer Carl Gauss, so also called as Gaussian distribution. So the normal distribution is also known as Gaussian distribution. So it is symmetrical, unimodal, and also it is one peak. Since it is symmetrical, it is mean, median, and mode are coincide. That is, all three are same. The tail are asymptotic to horizontal axis. That is, curve goes to infinity without touching horizontal line or horizontal axis. X-axis represent the random variables like height and weight, etc. Y-axis represents its probability density function. The area under the curve tells the probability. The total area under the curve is 1. Therefore, the mean equal to mu and standard deviation equal to sigma. So next we have some definition of the normal distribution. So only two parameters are considered in the normal distribution, mean and standard deviation. Same mean, different standard deviation. Same standard deviation, different means. Different means and different standard deviation. Here you can see this normal curve. It is based on the area. So in general, here we can represent the normal distribution in the range of -infinity to +infinity. Here you can see this standard score, that means Z value. So with this, here we can represent our mean, then variance, standard deviation. Right? So the symmetric curve is also known as bell curve. Right? In the normal distribution, the symmetric curve or the bell curve is also known as symmetric curve. It is also known as bell curve, right? So area under the curve, the mean value or the mean is ±1. The standard deviation covers approximately 68% of the area under the curve. The mean is ±2. The standard deviation covers approximately 95.5 of the area under the curve. The mean ±3. The standard deviation covers 99.7% of the area under the curve. So next we have standard normal probability distribution. So in standard normal probability distribution, mean is 0 and standard deviation is 1. Therefore, Z equal to x minus mu by sigma. Here Z means here we can represent Z score. Therefore, here Z is number of standard deviation from x to mean, also called Z score. Therefore, here x equal to value of random variable. So these are the basic problems for your practice. So normal distribution. The mean height of Gurkhas is 147 centimeter with a standard deviation of 3 centimeters. So what is the probability of height being greater than 152 centimeters, height between 140 and 150 centimeters? In the similar way, you have to do the remaining example for your practice. So I hope this is enough for this class. Suppose if you're having any queries, you can ask or you can call. Thank you. Thank you very much.